Hey guys, so today we're just going to be talking about Laplace transforms, and we're going to be using a piecewise function to find that. So today our piecewise function is going to be f of t, and from 0 to 3 our function is just 0, and from where t is greater than or equal to 3 our equation is t minus 3. So the first setup, when we talk about Laplace transforms, we want to take the integral. And in this case, since it's going to be two separate ones, we're going to have a proper integral and an improper integral. And so as you can see here, I've set it up. So our first one is just the integral from 0 to 3. And it's e to the negative st times 0 dt. So times f of t for this part of the integral, and then plus our other integral, which is our improper integral, so from 3 to infinity, and that's e to the negative st times t minus 3 dt. And so the way we do that, so now to find these integrals, we want to look at taking the limit as n approaches infinity. So what I did, I went ahead and first I took my derivatives and integrals there on the right side. And so we've got our derivative of t minus 3 is 1, and then our second derivative is 0. And then our integral of e to the negative st you can see below as well. And so we're going to start plugging those in. And so our very first integral is just going to equal 0, since that's what our function is. So we don't have to worry about that one. But now we have to look at the limit as n approaches infinity of this second integral. And so again, I went ahead and took the limit, and first I multiplied my t minus 3 times negative 1 over s times e to the negative st. That's our first term, and then minus, and that's just going to be 1 times 1 over s squared times e to the negative st. And again, that's going to be from 3 to n as n approaches infinity. So continuing on, then I just went ahead and plugged in. I went ahead and took our integral. We plugged in n and we plugged in 3, so that's why we have two separate parentheses now. So we've got negative n minus 3 over s times e to the negative sn minus 1 over s squared e to the negative sn, and then minus our second part, which is same thing, just plugging in 3. So then I went ahead and kind of put everything together, made it a little bit nicer to look at. And so as you can see here, we're kind of focusing on this first part of our limit because we want both of those terms to converge to 0. And so to do that, we need s to be greater than 0, because if s is less than 0, we actually get an undefined limit there, so that doesn't really work. So as long as s is greater than 0, both of our denominators of those first two terms are going to be exponential functions as n approaches infinity. So that's going to be way bigger than negative n minus 3 or negative 1. So those are both going to converge to 0. And then looking at our second set of terms, that minus negative 6 over s e to the 3s. So as long as s, again, is positive, we are able to move those e's to the bottom. So that's why I moved them to the bottom. And again, that first term is going to converge to 0. And then our second term, that negative 1 over s squared e to the 3s, that's going to be what our limit is. And so you can see that here. So that first part is just 0, and it's a minus negative 1 over s squared. So we have that. And then I just moved it over, moved e back up to the top. And the only caveat is that s must be greater than 0 for this to work. Because again, if it's 0, then it doesn't work for us. But yeah, so it's a pretty simple concept, I think. Hopefully this helped. And lastly, I'm just going to show a graph of our function. I've plugged it in here to my little Wolfram Alpha widget. And so this is our graph. You can see a piecewise function there. And yeah, you can see that there's no area from 0 to 3. The line is flat, so there's no integral to take. And yeah, that's about it. Hopefully this helped.